when it comes to, so we will be discussing about sample spaces. So sample space is typically identified as S or omega. Okay, so in the sample space, you should have set of all possible outcomes, which means like if you are looking at a coin example, for example, flipping a coin, then in the sample space, you are talking about all the possible outcomes for that event. So if you take tossing a coin, okay, so tossing a coin should have a head or a tail, right? So head or tail, because when you flip it, you see either this side, head, or this side, tail. So the event space means a different thing. Sample space means all the possible events that can occur in a given experiment. So if you are looking at sampling from the Faculty of Business, and finding the gender, say revealing the gender of your batchmates. Okay, so the gender can be either girls or boys, right? So this is what events, what a sample space is, all the possible outcomes. Okay, so when it comes to two tosses, say you are tossing this one 2 times, okay? Tossing 2 coins and tossing the same coin twice, they are the same events because one is not affecting the other. Okay, so tossing the coin can have, say, one coin may have a head, the other coin may have a tail. So you can have head, 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 tail, 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 or what? Tail, head for the coin, right? So both coins can have 2 different outcomes, head or a tail. And we discussed about waiting time for the bus to arrive last time. So you have a bus, okay, you go to the bus stop and you wait there. Okay, so you have the time, next time. So it can be starting from, say, this is 3 now on the clock. So by 3, maybe 5 minutes past 3, you may find a bus arriving, or maybe 10 minutes past that, so and so forth. But you never will find that your time measurement is negative. Therefore, all the time, the time measurement, or the time that will take, will be always positive, right? So you need to realize that when it comes to these kind of events, you can't count. You can't count the number of times something happens. Say, if it is the case of finding something, like counting the number of chocolates, the number of items inside a box, you can have 1, 2, 3, 4 a count. But when it comes to measurements like time, distance, height, weight, you can't have those values as discrete values, countable values. You always have some sort of an interval. So when it comes to time also, you are talking about an interval that can go from all the way from 0 to infinity. So in mathematics, we show it like S is X, where X can be a positive value. This can be. So this is how you tell the reader that it can be any positive value apart from 0. So because whenever you go to the bus stop, right, you may not get a bus immediately as you arrive, because even if it is a split second, okay, even if it is a split second, there would be a time. Therefore, that is why it is not equal to 0. Okay, so these are the events. So sample space is a discrete event. Okay, I'm going to use a different color. So a sample space is going to be discrete. It is going to be discrete if it consists of finite or countable infinite set of outcomes. So you can think about number of chocolates, number of items in a list, number of girls, number of boys. It is countable, finite, and it's you can say in terms of numbers without having decimal points. So a continuous case. Okay. So in the case of continuous sample space, we are dealing with number of events that can. So I'll switch off my video because I think that may also be a problem if I switch off. You may find it difficult to load. Okay, so in the case of continuous distributions, we are dealing with intervals. So it can be a time interval, right? Some measurement like height, weight. So you are dealing with things like this in continuous case. Here, the number of things can be the number of boys, number of girls, so on and so forth. Okay, right. Now, that being said, I think we are clear about what is a sample space and the discrete and the continuous nature of sample spaces. Now let's move on to the next part of the lecture. So we move from sample spaces. We've moved from sample space to event. What is an event? So an event is a subset of the sample space of a random experiment. Event is a subset of the sample space. Okay, what is a subset? Subset, in the case of a subset can have all the possible outcomes of a given set, which is, if you look at the event of head or tail, in this case, the event space, the sample space for tossing a coin is head or tail, right? Head or tail. So this, in fact, is a subset. So having a head or tail is an event, and it is a subset of all the possible outcomes, which means from the sample space, this is a subset. Or in the case of, say, head or tail, tail or head or tail, this is two coins, or one coin to be twice, or two coins at the same time. So if you ask someone, what is the probability, or show me only the cases where you get two heads or two tails. Okay. If someone asks you to show me only the cases where you get only two heads, or two tails, you have to take these two out from the sample space. So this is the sample space. This is the sample space. And you take out two events or two parts from these two elements from the sample space set, which is these two, HH or TT. Okay. So this becomes HH, TT, and this is known as an event. Okay. So event is a subset of the sample space of a random experiment. So events are generated when you need some sort of a calculation, some measurement from the given experiment, some sort of a measure. It can be the number of girls, number of boys, number of heads in a given experiment, or as I said, show me only the cases where you get two heads or two tails. Likewise, you have some sort of a criteria, and that criteria defines what sort of a set that is going to come out from the random experiment sample space. So that is an event. Okay? And the next thing that you need to remember when you are dealing with these cases is, I'm going to use a different paper, otherwise it's showing you the. So you need to know these words. A complement, not the compliment that you give to your friends or your respective other or better half. This is complement, not compliment. This is complement. So when you talk about complement, it means whatever that is not in the given set. So if you take, for example, a set, so this can be your sample space, omega or S, and you have an event like the two heads, like in this case, you have two heads or two tails, like this kind of an event. So the complement is, if this is a complement means whatever that is not belonging to A. So this part is A complement. You don't have A in the A complement. So we write this A complement. You can have A dash as well. This is equal to X, where X is not an element of A. So this is mathematical notation, but it's good to at least know what this means. It means whatever that is not inside A is considered to be the complement of A. Okay, that is one thing. Okay, when it comes to the union, The union means if you have a set, two sets like this. So this is your sample space again, all the possible outcomes. And then you have two events, A and B. So A union B means you can have things that belong to either A or B, this part. So either A or B means you have A union B, which is equal to any element where X is it is an element of A, or X is an element of B. So something like this example, let's say that you have this can be, let's say you are taking this subject, right? So the students who are taking DA1111, which is this subject. So you have students from A can be students from decision sciences, B can be students from FSM and other fields, not TS. TS complete. So A union B means the students who are taking this course and they belong to either DS or not from DS who have to follow the course. So this is the idea of union, either one or the other. On the other hand, we have another name called mutually exclusive. Okay. So mutually exclusive or disjoint. Okay. So mutually exclusive or disjoint means when you have intersection A, B as the null set. So we write this one as the null set psi. So null set means you don't have an intersection. The best example to remember is that if you think about A is girls and B is boys, so the intersection between girls and boys is going to be the null set, because biologically you have to have biological gender, you have girls or boys well defined, therefore they are mutually exclusive. Okay, so in the case of tossing a coin, head and tail, if you take head or tail, the intersection between head and tail is also going to be null, because you can't have, it's well defined two different cases where you don't have an intersection, or we call it mutually exclusive. So the three words that you need to remember is what is the complement and what is union, right? And what you mean by the mutually exclusive events, or the disjoint case where you don't have an intersection. An intersection is about the similarity of the X being part of both sets A and B, like the course that we have. Okay, so let's move on to the next part. So I have already used some examples. I'll draw them for you. Now, if you take a look at two sets, okay, if you take a look at this two sets, you have A and B. So this is the event space, the sample space S. This is how you draw something, some event. So this part where I'm going to draw as green, this green part, that is A intersection B. Okay. So when it comes to sets, you can have another type of set like this, where you have A and B separate, like in the girls and boys example. So you don't have an intersection. In this case, A intersection B is the null set, which means you don't have any element that belong to both sets, and these are mutually exclusive. So if two events are mutually exclusive, and if I ask you to draw a Venn diagram, there should not be any intersection between A and B. So the other thing is about subsets. So you have A and B like this. You have the set B and set A here. So A we write this C kind of a notation. This means A is a subset of B. Okay, so A being a subset of B means it's like this. So you have FOB students, FOB, all FOB students. So it's like this B set. So A set is like the DA students because it's a subset of FOB students. And we can call it a strict subset. A strict subset means always the subset will have lesser number of items compared to the other set. So because the number of DA students will be a strict subset, other department students will also be a strict subset because the FOB students belong to the large set, right? Okay, so likewise in the lecture slide you have other explanations for the A union B, A intersect, A complement, and so on and so forth. So I'm not going to go into details of them, just look at the diagram. So I'm going to go for an example here. We talked about the De Morgan's law last time. I'm just refreshing on them so that we can move from here. So this example, in the example, we have something called polycarbonate plastic analysis. So you have something like this. Okay. So you have high, low, and high, low scratch resistance. And here you have shock resistance. In the case of HH, which is high shock resistance and high scratch resistance, you have 40. Low and high, you have 4 and 1 and 5 here. So the sample of polycarbonate plastic analyzed for scratch and shock resistance, the results from 50 samples are summarized as follows. So just in the case of understanding them, you have HH, HL, and HL, LH, and LL, which means scratch resistance and the shock resistance can be low and high. You have all 50 number of samples present. Okay, so first thing you need to check if you get a question like this, check whether this particular thing, the number of thing, is equal to the total number, which is 50 given in the example. So we have 40 plus 4, 44, 45, and 50. So all the number of samples that have been taken are in this table. So you can follow up with the question. So the question asks us, what is the A intersection B if A denotes the event that a sample has a high shock resistance? A is the event where a sample has high shock resistance. So look at the things we have. We have shock resistance, high and low. So if A denotes the event that has high shock resistance. Okay. So A means high shock resistance. Therefore, look at the events you have shock resistance. Don't worry about the scratch resistance when you are dealing with shock resistance. Forget about this part, right? So you have A high shock resistance. That means this particular part belongs to A. And then it says B denotes the event that a sample has high scratch resistance. So B means high scratch resistance, like your mobile phone scratch resistance. Okay. So B is the event where you have high scratch resistance. So then forget about the shock resistance here. Forget about this. You have scratch resistance, high or low. And then the event means high scratch resistance. Therefore, draw another thing for the high scratch resistance. And this is your event B. So A intersection B means the point where the high scratch resistance and the high shock resistance intersect, which is this one. You can see the green and the red squares intersecting at this point, that is 40. So A intersection B is going to be 40. A complement means, so if you look at the A event here, you can see that A is this particular square that we have drawn. So any other thing apart from A is going to be the A complement. Therefore, A complement is going to be 4 plus 5, that is going to be 9. Okay. And the A union B, carefully look at this one. What is A union B? Okay. So A union B means you have A here, you have B here. So A union B means all the elements that belongs to A, B, or A or B, right? So you can see that 40, 4, and 1, they belong to this set. So 40 plus 4 plus 1 is going to be the A union B. Therefore, the answer is 45, 40 plus 4 plus 1, that is 45. All right. So samples in which shock resistance and scratch resistance both are high. So this is how you actually look at a problem. So in the exam, if you get a table like this, you should first look at how to properly segregate this like this, the problem like this, and to see how you can find out several items inside those boxes. Now, look at this point here. It indicates both are high, that is A intersection B. In the same line, along the same line, this particular cell, this particular value, it shows high and low for this event, which means A complement intersecting with B. So try to write these kind of things here so that you remember what it means. So here you have A intersecting with B. Here you have A complement intersecting with B. Here you have, this is B complement. So this little space here indicates A intersecting with B complement, and this is A complement intersecting with B complement. So this is how actually a joint distribution is formed. How you can see the distribution it has laid down on the paper. Okay, so that's about how to look at distributions and the tree diagrams. I will come to the counting techniques now. Okay. So what do you mean by counting techniques? We have what is meant by counting techniques. So counting in the sense is something that we do often to count the number of items in something. If I ask you to count the number of, say, I ask you now if you are a girl. Okay. So in a girl's wardrobe, you may have different dresses. So you have frocks and then jeans, and then you may have skirts, and then of course some other scarves and everything. Okay. So let's say that these are the things that you have. So if I ask you to count the number of items you have, if you know the number of frocks you have, you can say I have say 3 frocks. Number of jeans you have, you can say I have 2. For the skirts, maybe you have 4 skirts, and the scarves maybe 2. So if you know the numbers, okay, if I ask you how many items you have in your wardrobe, you can say that easily, just multiply them together. So you can have 3 plus 2 plus 4 plus 2 items in your wardrobe. If I ask you in how many ways can you wear a jean and a skirt? Like say this, you have 2 jeans, right? So say that one is a blue jean and the other one is a black jean. And the skirts, maybe one is red, one is blue, and one is white, and say there's another one, maybe beige color or something. Okay, I'll just say green, just make it easy for us to have letters. So RBWG respectively shows the color, and jeans, in the case of jeans, you have blue, black. So if I ask you in how many ways you can wear a jean and a skirt with different colors, so you can think about them, and you can think about, okay, I can wear a blue jean and a red skirt, okay, or I can wear a blue jean and a blue skirt. I can wear a blue jean and a white skirt. I can wear a blue jean and a green skirt. So if you carefully look at this, okay, your blue jean has repeated, and you have other options that are available from your skirts list. You have 4 skirts, it has been repeated for 4 times with different colors because you have 4 skirts, right? So the counting principle in general, the multiplication rule says, if you have number of different items, then rather than going for something like this, one by one, counting for the different combinations, you can simply multiply the available things together. So you have 2 jeans and you have 4 skirts. So just multiplying 2 times 4 will give you 8 possible combinations of 8 possible pairs. Because again, if you are going to write all these skirts with the color blue, sorry, color black, because you have already used blue color, then you will be doing the same pairs with black R, black B, black W, black G. So you have another 4. So all together, the number of pairs that you can choose would be 8. So the multiplication rule simply says, if an operation can be described as a sequence of k steps, then the total number of ways of completing the operation is going to be n1 times n2 times nk, which means all the possible combination, all the possible events, you can just multiply rather than counting or adding them up. Simply multiplying will do. So that's what it says. So why multiplication rule is so important in our case is because when you are dealing with countable sets like the sets that we say, you have a number of possible variations from those sets. Simply multiplying them would give you the answer. So that's why when we deal with, say, NCR or NPR, I'm using these concepts because you are already familiar with these things. We simply, rather than finding one by one, what we do is number of choices, say X times something, because the multiplication rule simply gives us that option rather than adding them up. You can, if you know the option, number of different options, you can just multiply and get the answer. So that's the idea of the counting technique, multiplication rule. This is the thing that we practice in this class, multiplication rule. Okay, so that's simply what it means, right? Let's go for permutations. So what do you mean by a permutation? This is part of counting techniques, and it is called so a permutation means a permutation of a set of elements is an ordered sequence of the elements. I'll tell you what a permutation is from a very simple example. So you can have cat. Say you have a word called cat. Okay, so you have a cat. Okay, so this is your cat. If you write it like this, you know it's a cat. But if you write the same letter combination like this, you don't know what it is. And if you write the same set of letters like this, you have a different meaning. So this may be something else, acting. So cat, act, and tack, they all have been originated from C, A, and T, right? So you can have another word out of this TCA which doesn't have any meaning. So you can have different meanings, of course, but I mean, in the context of that we are basing our discussion, we don't have any meaning for TCA. So a permutation of a set of elements means the CAT, similar to this, is an ordered sequence of elements. Now, choosing 3 letters from CAT, if I ask you to choose 3 letters from CAT, you can only have one way of choosing 3 letters because you only have 3 letters. So choosing 3 letters from this set, you only have one way of choosing, because the CAT or TAC doesn't matter because you need to choose 3 letters. But if I ask you to order 3 letters from this set, this is when permutation comes. Because like this, you can have different organizations, different orders for the same set of elements, right? So we have a little equation for this. It's actually some formula for this. So I will keep it aside and I will derive that formula. So imagine we have set of elements like the case of cat. So you have C, A, and T. Okay, if I ask you to focus this, if I ask you to organize them, right? If I ask you to organize them, you can have, say, 3 spots. Okay, so in the first row, you can have 3 possible letters for this first spot. So it can be C, it can be A, or it can be T. So there can be 3 possible choices that you can fill in for this first space. So once you have taken 1 letter out of these 3, for the second step, you can only have 2 other letters. Likewise, by this time, you have already filled this. So you have only 2 letters left. By this time, you have already filled the 2 possible things and you have only 1 here. So such cases, the number of permutations of these 3 different elements can be written as this. So this factorial sign, or 3 like this indicates that you multiply the value starting from that value all the way to the number 1. So n factorial, or this sign, indicates you are multiplying the value starting from n all the way up to the original point, that is 1. So it comes from the number of permutations that you can have for different n elements. Okay, so imagine that you don't come all the way up to this. So what I ask you to do is, I'm asking you to use these 3 letters, and I tell you, okay, you know what? I don't need to have 3 letter permutations. I want you to select only 2 out of these 3 spots, out of these 3 letters, and write a letter, write a combination. So I only have 2 spaces. So for the first space, I have 3. For the second space, I have 2. Okay, so that is simple, and it's the same because you only left it 1 letter at the end. But imagine that a letter like this, for example, a case like apple, and I ask you to use these 5 letters and fill only 3 spots. So you may you have the options, 5 options at the beginning. Then after filling this space, you have 4, and then you have 3, because you have more options than the available spaces. So in such cases, the way that you can arrange 5 times 4 times 3, that is equal to 60. 5 times 4 is 20, 20 times 3 is 60. So how do we represent this? In order to represent such case, we can use the factorial sign. And then if you take a look at this 5 times 4 times 3, this is the same thing as 5 times 4 times 3 times 2 times 1, and then you remove this part, this 2 times 1. If you can remove this, it's the same thing. So how do we remove this part in a multiplication? You can divide this by the one that you want to remove. So that is 2 times 1. In fact, this 2 times 1 is none other than, this 2 is in fact 5 minus 3, which is the number of choices you take from the available 5 letters. Therefore, this is none other than just the number of available things and the number of spaces that you are going to fill with your permutation. Therefore, we have this factorial n divided by n minus r factorial, and this is considered as NPR. So this is the number of permutations. So what you need to realize is that when it comes to number of permutations, you consider the order. The order is important because it's not about choosing. Okay, so it's not about choosing, it's about ordering things. If you want to order apple in a different way, it's also NPR. You take some letters out of it and you order it. So this is how you organize the number of permutations of n, all the possible things, like the case of your wardrobe example here. So you have 3 frocks, 2 jeans, 4 skirts, and 2 scarves. So if you want to have all the number of permutations in which you can order your dresses, so the total number of possible ways you can order, your wardrobe is going to be 3 to 4 plus 3 plus 2 plus 4 plus 2. That's going to be 5, 9, and 11. You have 11 items in your wardrobe. So all the possible, like, you don't want to care about all the possible, like whether you take a scarf and a frock and even though they don't match, you don't have to worry about it. So all the possible combinations, all the possible permutations is 11 factorial, because you have 11 items. And in this 11 items, you have 3 frocks, 2 jeans, and 4 skirts, and 2 scarves. Therefore, the ways in which you can order them, you need to divide them by the same things like this. So this is the total number of unique permutations that you can make when you have different types of items. So it's the same thing that happens in the NPR case as well, but the difference is that when you have more than one specific set, it's not a choice, you have several other items. Right, so that's about permutations. Then we come to the next part of it, that is known as combinations. So a combination is known as NCR. I'll write you the equation for that, or the formula for this. Factorial n divided by factorial r, n minus r factorial. So if you carefully look at this, okay, this is actually NPR, because NPR is factorial n divided by n minus r factorial. Okay. The difference in NCR is you have this r factorial. So what is r factorial? R factorial is simply the number of ways in which you can organize a given set of R objects. So you remove that in the NCR because you are only worried about the choice you make. Like in the example I gave you earlier for the cat, you have 3 letters, and the combination, in the case of combination, you don't care about the order that you are going to put them. So if I ask you how many ways in which you can choose 3 out of these 3 letters, 3C3 is going to be factorial 3 divided by 3 factorial, 3 minus 3 factorial. The factorial of 0 is 1. Okay, so this is 1, and this is going to be 1. But in the case of NPR, in this case, because 3 is the same thing, so if I ask you 3P3, taking 3 out of it, 3 factorial, 3 minus 3 factorial, so that is going to be 3 factorial divided by 1, 3 times 2 times 1, that is going to be 6. So you can see the difference. You can choose only one way because you have only three elements. You can pick 3 out of this 3 only one time. It's just one way, but you can organize them in 6 different ways. So that is the difference between combinations and permutations. So unless you do some questions about these things, it's difficult for you to exactly say what they mean. Now, that being said, so we have done some work about permutation and then combinations. So we come to the point of talking about probability. So what do you mean by probability? So a probability is a number between 0 and 1 that is used to quantify the likelihood or chance that an outcome of a random experiment will occur. So in the case of cat, I'm going to go with the cat example. If you look at the cat example, okay, the probability of finding A in this set is going to be 1/3 because you have only one A inside cat. So if you say apple, the probability of finding P, in this case, there are 1, 2, 3, 4, 5 letters. The total number of letters is 5, and you have 2 P's. So the probability of finding a P in apple is 2/5. Finding a A in a cat is 1/3. So the probability is simply the number that an outcome of a random experiment will occur. So when I marked your mid-exam papers, what I saw was some of them have found probabilities that are greater than 1, which will never happen in your cases, in the things that we deal. This can happen in quantum mechanics. It's a different scenario. We don't have to, I don't think you will ever deal with those things. So in classical probability theory, probability will always be between 0 and 1. So you cannot have a probability answer which is greater than 1. Remember this. If not me, anyone who sees that you have answered a probability that is greater than 1, then, or a negative probability, then they definitely know that you don't know about probability. You haven't even got the concepts of probability. So first thing, remember, probability is always greater than 0 and less than 1. A value will always be a decimal value or a percentage. So if you are going to give a percentage value, again, percentage values will never go beyond 100. So it's 0 or 100%. Otherwise, it is 0 or 1. Okay, remember this very carefully. Note this down. Probability can never be greater than 1 or less than 0. Okay, so that's about probability, the basic concepts of probability. So we have talked about the, I'll go with this example. Okay, so statistics class of for engineers. So this is the example that I have in my lecture slide. So I will explain this. So a statistics class. Okay. A statistics class for engineers consists of 17 mechanical, 15 electrical. So this is mechanical. So you have 17 mechanical and 15 electrical and 10 civil. Now 10 civil and 8 chemical engineering students. So you have 8 chemical engineering students. If a person is randomly selected by the instructor to answer a question, so in this class, they are sitting like this. Okay, they are sitting like this. So you have 17 mechanical, 15 electrical, 10 civil, and 8 chemical. So they are sitting inside the classroom, and the instructor is going to ask a question from them. So the first question is find the probability that the student chosen is a mechanical engineering student. Next student. So you have 17 mechanical students. Okay, and also you have several other students as well. So you have mechanical 17. Then out of the total number of students in the set or in the class is total number of students in the class is 17 plus 10 plus 15 plus 8. That's going to be 15, 8 is 23, 23, 17, that's going to be 40, 40 plus 10, that's 50. So you have 50 total students. And out of this 50, 17 students are mechanical students. So the probability of being a mechanical student is 17 over 50, which is going to be 0.34 or 34%. Okay. So if you multiply this by 2, that's 34, then this is 100, 34 divided by 100 and 0.34 or 34. So 34%. So this, because it's always a fraction, in the fraction you have always the total number of possible outcomes of the sample space. You always will have a value less than 1. Okay, so that's the rationale behind why your probability will always be less than 1. So the next question that they ask is find. Okay, the next question in the list is find the probability that a chosen student is going to be a civil engineering student or a chemical engineering student. So how do we find it? Now let's go back to the original discussion. You have A or B here. So mechanical 17, chemical 8, electrical 15, and civil 10. This is the number ratio that the numbers we have. So chemical or civil means it can be a chemical student or it can be a chemical student, either of them. So in this case, you can have 8 chemical students or 10 civil students. So all the possible number of students is 50. This is 8. This is 10. So altogether you have 18 chemical or civil students. So 18 out of 50, that is going to be 0.36. Yeah, or 36%. You need to answer it like this. Otherwise, if it is, you understand what I mean. So the value should be between 0 and 1. Okay, so you have the answer as 0.36. Okay. Now let's go on for the axioms of probability. When it comes to axioms of probability, so axioms, the word axioms means these are not proven inside, but we agree on. It's like if you look at a human being, like you know that the human beings walk upright. They have two eyes, one nose, two ears, one mouth, two hands, two legs, right? You know how a human being look like. So axioms of probability are like that. We agree on these things, and these are the fundamentals of probability, and this is the basis of. So the total probability, which is the total number of events that can happen, the probability of that is going to be 1, because that's kind of the reality, that's the world that we live in. And always the probability of an event should be between 0 and 1. And this is the most important thing of this. If two events are mutually exclusive, that means they don't have an intersection, then the probability of their union, like the number of girls and number of boys, right? The probability of finding a girl or boy, right? The probability of finding a DA student or someone else in the faculty of business. Likewise, if the two sets are mutually exclusive, then the probability of finding A or B, the union of that, is going to be the probability, addition of the probabilities for the mutually exclusive events, because you don't have an intersection. If you remember from your O levels, I hope you remember the number of items in A union B is NA plus NB minus intersection of this. So if an event is mutually exclusive, you don't have this, therefore you have NA plus NB. So and this divided by the total number of events will give you, so basically this one. Okay, so that's how this happens for mutually exclusive events, right? Okay, so that's about axioms of probability. And then this is about axioms of probability. Then you have properties of probability. So I'll write down the properties of probability, some important properties of probability. So the complement, the probability of A complement is always 1 minus the probability of A. The probability of the null set is 0. The probability of A union B is equal to, from this expression, probability of A union B is PA plus PB minus PA intersection B, right? And then there's another one that is, if A is a strict subset of B, then the probability strict or in a subset of B, then probability of A is less than or equal to the probability of B. So these are the some of the probability, some properties of probability that you need to know. Okay, so that's about probability. Now I'm going to go for a question. Okay, so the next question in the lecture. So the question is, okay, if the probability is, that an automobile mechanic will serve 3, 4, and 6, 7 or more hours on given work day are respectively 0.1 to 0.9. So I'll write it like this. The probabilities that a mechanic will serve 3 days, 4, 5, 6, 7, 8 or more hours on any given work day are respectively. So the probabilities are 0.12, 0.19, 0.28, 0.24, 0.10, and 0.07. So the question is, what is the probability that he will service at least 5 cars? So the question is, what is the probability that the mechanic, he will service at least 5 cars on his next day at work. So at least 5 cars means the number of cars can be 5, 6, 7, 8 or more. So basically, at least 5 cars means you can have 5 cars, 6 cars, 7 cars, 8 or more. This is what it says. So we know that if you have, say, you can find it in 2 different ways. One way to look at the problem is you can add the probabilities of having 5 cars, 6 cars, 7 or 8 cars. Okay? Or you can look at this one in a different way, because the probability of A complement is equal to 1 minus probability of A. So if you take the event A to be the probability that he will service at least 5 cars, if your A is this, then your A complement is going to be the probability of that person servicing lesser than 5 number of cars. Okay, so because 5 is included, probability would be servicing 3 or 4 cars. Okay, so the P of A complement, if you take A to be this one, the probability that he will service at least 5 cars, then the A complement is going to be the probability that he will service lesser than 5 cars. So lesser than 5 cars means you can have 3 cars or 4 cars. So the probabilities of those values have been given as 0.12, 0.19. So 3 or 4 cars. Therefore, the answer is 0.1131. Okay. Now, this is not what we want. We want PA, the probability of servicing 5 or more cars. So that is simply PA is going to be 1 minus P of A complement. So that is going to be 1 minus 0.31, and the answer is 0.69. So actually, this is a good thing to know. I mean, the relationship between the complement and the probability of an event. Okay, so that's it. And I'm going to go with another example. The next example on the lecture slide is John is going to graduate from an industrial engineering department in a university by the end of this semester. So John is going to graduate from an industrial engineering department in a university by the end of the semester. After being interviewed at 2 companies he likes, he assesses that his probability of getting an offer from a company A, so I'll write only the important part here, that his probability of getting an offer, okay, probability of getting an offer from company A is 0.8. And his probability of getting an offer from company B, the same thing from company B, is 0.6. Okay. Now, he also believes that the probability that he will get offers from both companies. So offers from both companies means A and B, because offers from both companies indicate that both companies would like to take him. So A says, yes, we like to hire you. B says, yes, we are looking forward to hiring you. So both means A and B. So whenever you have AND logic, it means the intersection between the 2 events. So A and B. So the probability of this is 0.5. So let me formally write this. Probability of A intersection B is 0.5. Probability of A is 0.8, and the probability of B is 0.6. Right? So you have this. Now, what is the probability that he will get at least one offer from these 2 companies? So at least one offer from these 2 companies means, this means you can have an offer from A, you can have an offer from B, or you can have an offer from either of these. Okay. So when I say A or B, okay, which means A union B. So you are asked to calculate the T of A union B. So in the exam, if you find it difficult to understand whether it should be A and B or A or B, what is it, whether it's an intersection or a union, look at the question. If it says what is the probability that he will get at least offer from both of these companies? Or if it says offers from both companies. So if you say, if the sentence has a meaning of and, it means the intersection. If it means either or, either A or B, then it means the union. Okay. So if it is about union, the question asks you to find the probability of A union B. So if it is difficult for you to remember the equation for this, which you should not be finding difficult because this is taught in O levels. So if you are looking at A union B, this is simply A union B means you have A plus B, okay, A plus B, and then minus, because this intersection part is added twice, you have to take this down, A intersection B. So simply the P of A union B is P of A plus P of B minus P of A intersection B. So this is going to be the P of A is given in the question. The P of A is 0.8. So P of A is going to be 0.8. And P of B is also given. P of B is 0.6. And P of A intersection B is given. Where both companies would like to hire. So that is 0.5. So the answer is going to be 0.9. So this is how you tackle a problem like this. Okay. So now we only talked about events where you have probabilities defined for one event, one single event coming from A or B or one single event. Conditional probability, which is the next topic. Conditional probability. So by conditional probability, we mean that we have an event that happens conditioned on some other event. So it's like this. So you buy a chocolate. You buy a chocolate, given that you are on a date. So this means basically if you say that A is the event of you being on a date, and the event B is you buying a chocolate. So the conditional probability basically means the probability of B given A. So you have this straight line indicating that B happens after A. So the thing that happens after the first event comes first. So A happens first and then B. So the conditional probability of PB given A means A happens first and then B happens as a condition of A. So you being on a date and you buying a chocolate. So the probability of you buying a chocolate given that you are on a date. So PB given A. This is equal to the probability of A intersection B divided by probability of A. So how does it happen? The probability of A here comes from the fact that you being a date is the main condition that B happens after. So you being a date comes as the total probability right here. So if you remember, the probability is defined as the total number of events that can happen in the sample space. So PA comes because the probability, the conditional probability is based on A. So that's why PA comes at the bottom. And A intersection B means the number of times you will buy a chocolate in a date. So N comes here, A and B. So buying a chocolate and being in a date, on a date. So this is how actually this equation happens. It's a very simple equation, remember, but it's very powerful because most of the things that deals with these Bayesian theories and everything happens because of this conditional probability equation. So this is the idea of PB given A. Now the same set of axioms that we discussed previously is applicable to all these all the conditional probabilities as well. So the first condition is that PA should be greater than 0, which means you should be going on a date. That this event should happen. So if you don't go on a date, then PA will be 0. Then buying a chocolate condition on a date, even in mathematics, it cannot be defined. If you don't go on a date, then this doesn't exist. So the probability of A being greater than 0 is the first condition. It has to be satisfied. That means the first event should happen. The basic thing is that the first event should happen. So happen means it doesn't mean that it should always happen. It means that it should be a defined event, which means the probability should always be a positive thing. So, maybe you being on a date, maybe it has a probability of 0.00001 or something, but still you have a defined event, right? Like you being you should have some positive probability for that. Okay, so that should be there because it comes from the denominator. DA should be positive. And the other set of axioms is that P given A should satisfy the axiom that the sample space given that event is equal to the one, because if A is the given that the sample space happens, because sample space the A is a subset of sample space, therefore having the total set of events happening given that A is happening is actually 1, because that happens, and it's always between 0 and 1. Okay, and if this is also an important thing. If two events B1 and B2 are such that B1 and B2 are mutually exclusive, then the union of this is equal to simply adding them again, like in the normal case, like in a simple example, B2 is the addition. Okay, so it's like girl and boy is mutually exclusive. So A means being in maybe event A may be taking a sample from being in the DS department. So the event tree would go being in the DS department, not being in the DS department, and being a girl and being a girl, being a boy, being a girl or being a boy. So if I ask being a girl or being a boy is mutually exclusive, if I ask you what is the probability that you being a girl or a boy being chosen from not from DS department, so that happens like B union B1 union B2 given A, which means given not from DS, so it goes like that. So this and this, which means this arm and this arm. Okay, so that's how this happens, right? So we have conditional probability going all the way here. So I'm going to use this example, one example, to talk about conditional probability, and I'm going to. So we have table male, female. Okay, so we have employed and unemployed, employed and unemployed. So we have 460 male, 460 male, 40 unemployed males, females, 140 employed, 260 unemployed females, right? So this is just a table, right? This is something that you can even find just by looking at a survey. So you have employed males, employed females, and unemployed females. This is like a table that you get. So the question is, what is the probability that one chosen one is employed given that a male is chosen? Okay, so what is the probability that the chosen was employed given that a male is chosen? So the probability here, in fact, depend on you choosing a male. So that is the first event. So if you draw the event diagram or event tree, you can choose a male or you can choose a female. And the chosen one, choosing a male or female, that person can be employed or unemployed. Employed or unemployed. Okay. So when we tell that what is the probability the chosen one is employed given that a male is chosen, given that a male is chosen means the first event, choosing a man. So it happens on this arm, choosing a man, and the probability of employed. So you look at backwards, probability of a person is employed given that a male is chosen. So let's define in the space. So M, if you take M, a man is chosen. Okay. And let's say E, the chosen one is employed. Chosen is employed. Okay. So if you take a look at them, so the P of E given M is equal to, in fact, look at this table. Now, choosing a male from this set, how many adults are here? 460, 40, that is 500, 140, 260, that is 400. So 500 is here, 400 is here. You have 900 of total, 900 total number of people here. So in this one, choosing a male, okay, choosing a male, which is this, if you take P E given M, that is going to be P intersection M divided by PM. So choosing or being a male in this set is going to be, so you have 500 males, 500 divided by 900. Total of 900 people are there. And E intersection M means, like we did in the previous case, just draw a little square. So you have E intersection M, this is what you want. So first of all, draw the employee thing. And then draw the male square like this. So E intersection M means where the two squares overlap. So two squares overlap at 460. So E intersection M means 460 divided by 900, because the probability of this intersection is 460 out of the total number of 900. Therefore, 460 divided by 900. So in final case, this 900 cancels out. So the answer is 460 divided by 500, that is 20.92. Okay. So now you can see that the total number, which is 900, becomes cancelled in both cases, and these two values come as the answer. So 460 is the intersection between employed males, and 500 is total number of males. So if you know this table, right? If you know this table, and the question is, what is the probability that employed, given that a male is chosen, you need to first look at the number of males. Just look at this. So the number of males available is 500. And then you can see employed and unemployed, and look at the employed number. Then 460 divided by 500 will give you the conditional probability of PE, because the 900 becomes cancelled as it is the base of this. Okay. So, okay, that's about the conditional probability. The next thing is the multiplicative rule. So a multiplicative rules come when you have an intersection. So it comes from, basically it's very simple, because it comes from this little equation here. PB given A is PB intersection A given that PA. So just by simple manipulation, we can take this one to this side and then say the intersection between two events is equal to PB given A times PA, because you just multiply this side and this becomes this side. So PB intersection A, PB given A times PA. And then you can write another one, because for the other case as well, if you flip A and B, we still get the A intersection B and B, probability of B at the bottom. Again, the B intersection A becomes this. So both of them are the same, B A given times PB. So both of them are equal to PB intersection A. So this is used in something called total probability theorem. So I will talk about it later, but before we wind up today's session, okay, I need to tell you something about independence. So independence of an event, So independence of an event is if two events A and B are independent, then PA intersection B is equal to PA dot PB, which means you can simply multiply. You have been doing this for throughout the lecture series, because whenever I ask you what is the probability that you get two heads or two tails, remember, you just drew the tail head tree diagram, and then what is the probability of having T and T, then easily just multiply along this arm, probability 0.5 times 0.5. So because they are independent, so that's what it says. A and B is equal to PA dot PB if A and B are independent. And the next thing is, if A and B are independent, the probability of A given B is equal to PA, because there is no condition, right? And the probability of A happening is rest assured. If it doesn't matter whether B happens or not. if even though B is defined as an event that can happen. Again, or other way around is also the same. B given A doesn't happen because even if A is given, if they are independent, so given probability is the same probability as them, because this happens because of the equation that P A given B is equal to P A intersection B divided by P B. So because because of independence, A intersection B is equal to P A times P B. Therefore, P B cancels out. Then this is the same as this. You can see the given probability becomes the same probability if they are independent. Okay, the next thing is if events are independent, if A1, A2, A3, all these things are independent, like students from different departments, it should be an independent case, then the probability of intersection for these events is going to be the multiplication of the probabilities of those events. So although these are somewhat abstract as it seems, these are very important concepts when it comes to understanding some questions that you find, some problems that you find in reality. Okay, so right, next lecture I am going to talk about probability distributions starting from Bayes theorem. So let's try to do this session maybe for Tuesday after your maths lecture, first maths 1. Before maths 1 lecture, maybe during the lunchtime, I will try to finish this because I need to finish this by at least next week so that you are familiar with the topics. You will have this recording, so you can just refer to it in your leisure time and just try to wrap up the things before your final exams. Regarding your mid-exam results, I'm not really happy. So most of you got really low marks. Okay, so this is a serious problem because even the basic concepts that we discussed were not really identified. So I'm a bit disappointed actually because some of them have written probabilities greater than 1, right? This is, it's really unacceptable because probabilities are between 0 and 1. We even talk about it very often. So again, when I ask you to count the number of things, some of them have written decimal answers, right? Which is, it's totally off. Okay, so we need to consider about these important things. Particularly, it's not about mathematics, right? I know that you haven't done mathematics in your A levels. It's not a big thing, but you have to have common sense. That's the main thing that I found difficult to follow. That like people have not got common sense. Like some of the things I can bear with, but some of the very silly mistakes, I don't think that we should entertain such things. Anyways, I need you to complete the remaining parts of what you have missed in the previous lectures as soon as possible, because things will pile up as you learn about new concepts like sampling and all. So I need you to complete them as soon as possible. So next week I will try to finish the probability distributions. And my suggestion to you is when I do these classes, don't just sit back and watch this kind of a video. Just try to do it with me. Write this, take your lecture notes, write something. If you don't write, because for me, I have done mathematics and I've done engineering and I have done higher studies in mainly in probability and computational mathematics and computational geomechanics and all these things. So I am familiar with mathematics. This is what I do. So some of them I can, I remember, and I cannot relate how difficult it is for you to relate them. Okay. But if you don't practice them, the problem will be the time will pass and you will not learn anything. So at least try to do a very simple question. Like it's very simple. Like the questions that we discuss, even about the examples that I have taken, these are very simple things. Even if you don't understand them, if you write them on a piece of paper, if you write 2-3 times, then at least you will remember what you did. So because you have time. But with time, if you think that someday you will learn these things just by looking at them, and you'll never learn. You will never learn anything like that. Even if like most of you have come from commerce backgrounds, if you don't know how to do the ledger accounts, you don't know how to balance an account, if you don't know the basics of what is debit, what is credit, what is an asset, if you don't know what it comes as what is the ratios, the interest rates, if you don't know the concepts behind them, you can't do anything. So probability and statistics is for you, like for your entire semesters to come and for your careers in the future. So please learn it when you can. That is the best advice I can give you. Don't think that you will learn it in the future when you have other things, which will not happen. So now you have time, now you have a specific dedicated module for this. So take a piece of paper, do your math and learn it. Then otherwise you will never learn.